Hello and welcome back. This is part 2 of simplifying linear expressions by combining like terms. Just a quick review what we did in part 1. We identified the like terms in each linear expression, and then we combine them. So our 7z plus 3z, 7 times some number z plus 3 times some number z gives us 10 times some number z, and negative 12 plus 9 gives us negative 3. Same thing with next expression. Combine our like terms, and we arrive at an equivalent linear expression, meaning if I plug the number or evaluate this expression and this expression at the same value, I would get the same number. All right. So what are equivalent expressions? Equivalent expressions have the same value. Well, what does that mean? That means that if I say these two are equivalent, that means that if I evaluate the expressions with the same number for z, I would get the same value. So for example, let's say that z is equal to 2. What would be the value of this expression, and what would be the value of this expression? Well, if z is equal to 2, then the first expression is 17, and so is the second expression, 17. So those expressions are equivalent expressions. Therefore, we have so far generated equivalent linear expressions. That was our goal, by combining like terms. No parentheses and no like terms. Okay, so let's practice simplifying the following linear expressions, and if they're already simplified, say or write simplified. I like to use a chart, especially when I have a lot of different terms. This expression has 1, 2, 3, 4, 5 terms, so I'm not confused. I go ahead and make a chart and put all my terms together. So I have t terms, I have n terms, and I have constants. I'll explain what I mean by that. So my t terms are negative t, or the opposite of t, and negative 12 times some number t. My n terms are negative 16 times some number n, and plus 21n, and my constant term is 7. So now I can clearly see I have to combine negative t and negative 12t. I get negative 13 times some number t. Negative 16n plus 21n gives me 5 times some number n, and there is no other constant, so all I have is 7. My equivalent expression, or equivalent expressions, and they're simplified, and I've simplified it. Okay, the next problem. There are only 4 terms here, so I'm not going to use a chart, but I'm going to circle my like terms and put a triangle around the other like terms. So my a terms and my constants. So I'm going to combine my a terms, 9/16 a, and a negative 3/8 a. You need to find a common denominator, which I'm going to use 16. 9 minus 6 gives me 3. So when I combine my a terms, I get 3/16 times some number a. I combine 9/4 and negative 5/8. Common denominator, 8. 9/4 is equivalent to 18/8. 18/8 minus 5/8 is 13/8. We'll go ahead and convert that to an improper fraction. A mixed number. Again, I simplified the expression, and they are equivalent. I simplified it by combining like terms. Should be able to squeeze one more in here. 3 times some number p minus 3 times some number k plus 7 minus 6 times some number p plus k minus 8. I'm going to use a chart for this one. My p terms are 3p minus 6 times p. My k terms are negative 3 times k plus k. And my constant terms are 7 and negative 9. So I'm going to combine these terms. That's supposed to be a k. So 3 times the number p minus 6 times the number p. It's not right. It's supposed to be 3 times some number p, negative 3 times the number p, minus 2 times k minus 2. So let's get the final answer here. Minus 3 times some number p minus 2k minus 2. All right. I still can't write a k. I'm sorry, guys. I'm not good at writing k's. All right, guys, it's a k. Okay, so we're going to stop right there, and we'll finish this up when we come back.